All right, so for this section, we're dealing with proportions and similar figures. Once you get the setup, it's just like solving for proportions with our cross multiplication, but the setup is what is important for this section. The first part we're going to talk about is how to set up triangles and setting up similar triangles. So similar figures have the same shape but not necessarily the same size. And this symbol right here, oops, that I just covered up, indicates that they're similar to. So we can see here triangle ABC is similar to triangle XYZ. So as we go through setting up, and some of the problems you'll see later with setting up triangles that are similar, we like to look at how it's written, and then we can label in the same corresponding letter the second triangle. So if we look at this, like our A is listed first, that is corresponding with our X. Our B is second, corresponding with our Y, and our C is corresponding with our Z. So if we look at where these letters A, B, and C are in this, that lets us know where we would label our X, Y, and Z. So A is here, so X would be here, Y, and Z. So you want to look at where they would be in relation to each other here. All right. Now, another way to think about it, because we're going to talk about sides of triangles, would be like side XY right here. So we can see this side, and down here we're going to be listing them as two letters to indicate a side, but side XY would be similar or correspond to side AB. So looking down at this section, which sides of the triangles are similar or proportionate? You can see we have AB right here, and that's the same as our XY. Right? So if I look at the next example, if I look at BC, and what side is looking the same as BC, that would be YZ in the second one. And of course, finally, we have AC, and that would be our X, or our XZ right here. That would be similar, so when we're setting those up. This is going to come into play on the next page when we do a couple of the examples of setting up our ratios. The next thing we talk about in relation to these is what a scale drawing is. And what a scale drawing is, it's a large or reduced drawing that is similar to the actual object or place. So I like to think of like maps on this. Like a lot of times you have a map, on a map like 1 inch might stand for 10 miles. If we know that information, we can set up our proportions to figure out how far something would be. In this example, the 1 inch for 10 miles, how far would 3.5 inches be? Well, we could just multiply 3.5 by 10, it gives us 35. But if we stick with what we're good at in setting up the proportions, we can set it up like this and cross multiply. So we have 1 inch to 10 miles, because that's a ratio right here. We can set it up as a fraction. How far would 3.5 inches be? The inches is on the top along with this one under X miles. So as we cross multiply, we have 1X equals 10 times 3.5, which is 35. So that's already done. The reason it's good to get in the habit of setting up like this is because then you can answer a question like this. If 2.5 inches equals 10 miles, how far would 8.7 inches be? All right, so if we're still doing it on a map, we can set up our first proportion as 2.5 inches to 10 miles. We know the inches, we don't know the miles, right? So we have X miles here and 8.7 inches. So then we again can use cross multiplication to set up that problem. So 2.5 times X gives us 2.5X. 10 times 8.7 would be 87, and then we divide by 2.5 to solve for our unknown miles. So I bring up my calculator. So 87 divided by 2.5, that gives me 34.8. So on a map, in that case, it would be 34.8 miles. It's important to note that when setting up the proportion, that the units are on the same side, just like we've done in the previous sections. So depending if it's the top or the bottom. So for example, if I said 10 miles to 2.5 inches, I would have to set up the unknown, or the 8.7 on the bottom, and the unknown on the top. When we cross multiply, we still get to this step. So as long as you set it up consistently, you'll still get the answer. All right, so the next examples we have triangles below that are similar, then we can find an unknown length. So if we look at this, we have AC is 14 centimeters and CB is 32. And as long as these are similar, which they are given, we then can find our unknown of DF. We can call that X. So we can set this up in multiple ways. We can compare 14 to 32 to X over 24. So we can say 14 over 32 equals X over 24, because this is in corresponding with X. This 32 is corresponding with 24, so they're on the same side here. We could compare these two sides of the similar triangle. So we can say 14 over X, for example. So this over that, but then we would do the part of this triangle over the 24. All right, so that's another way we can set it up. You could set it up backwards. You could say 32 over 14 if you wanted to. It's not backwards, just a way that you would choose it. But then, because the 32 is listed first here and the 14 second, we listed 24 in the X second there, right? 24 over X. And then, of course, you can flip these around and do it again. So there's 4 ways you could really set it up and still get the right answer. When you cross multiply, 32 times X, 14 times 24. 32 times X, 14 times 24. 32 times, that should be an X, 14 times 24. You're still going to get your correct answer. So being able to set up or draw the triangle, even if it's given, to label the sides and figure out where you need to be. So if we look at this, we have 32x equals 14 times 24. That gives us 336. And we divide by 32. So my unknown side would equal 10.5. All right, so how could we use this in application? I always like this example because I think it spells it out and it kind of gives you a visual, and we can actually go out and do this on a sunny day. You can use proportions to figure out how, for example, how tall a tree is. How do we do that? Well, if we know how tall we are or another object and we measure the actual shadow, you can see here we're kind of setting up a triangle, right? We have a 5-foot tall triangle and a 4-foot tall long shadow. Now we can't get a tape measure up to the top of a tree, but we can measure from the base, we can measure the shadow of the tree. So in this second triangle, you can see we have 10. We don't know how tall the tree is, so that would be X. So we're setting up a similar triangle here. Again, you could do 5 over 4, X over 10. You can do 5 over X, 4 over 10. It doesn't matter. I'm going to use these two. So what if I do 4 over 5, right? This over that. Then I would have to set up 10 over X for this second one. And then we cross multiply. So we have 4X equals 5 times 10, which is 50. Divide that by 4. And we have our height of our tree is 50 divided by 4. That gives us 12.5. All right. So we got a couple other examples here. Go ahead and pause this and try it, and then we'll see how you set it up. So a tree casts a 26-foot shadow. I'm just going to draw like a triangle. Here's my tree. Here's my shadow. I know that's 26 feet. A boy standing nearby casts a 12-foot shadow. So here's the boy. Here's his shadow, 12 feet. His height is 4.5 feet. So we can set that up, and you can kind of see our triangles here. If we're setting that up, how tall is the tree? Well, this is our unknown right here. So we can do X over 26 equals, since I did the X first, 4.5 over 12. And then cross multiply, get your answer. 12x equals 26 times 4.5. Gives me 117. Divide that by 12. X equals 9.75. So that's the height of the tree. So again, same type of problem, setting it up. House casts a shadow of 56 feet. So here's our house. Here's our shadow, 56. Girl standing nearby casts a shadow of 7.2 feet. Her height is 5.4. Again, x, exact same type of problem. You can do x over 5.4 if you want. Equals 56 over 7.2. That's one of the 4 ways we could set it up. 7.2x equals 56 times 5.4, 302.4. Divide that by 7.2. Our x equals 42. All right. To add another example, all right, some of the questions you might see are dealing with triangles. So we might say triangle ABC is similar to triangle DEF. Okay, so let's pretend here, let's just say here we know this. And we can say if, I'm going to make this not a little bigger, if AB equals 20, BC equals 10, and let's say EF equals 6, how much does DE equal? All right, so let's draw this out as a triangle. So the first thing we talked about was how to label our triangles. So if I just draw any shape of a triangle, it doesn't matter, right triangle, whatever. So here's a triangle. I'm going to label this A, B, C. All right, I'm going to draw my second triangle. That's similar. I'm going to label the A in the same spot as, or the D in the same spot as the A, and so on, right? So if I have A, B, C, D, E, F, D, E, F. So now the picture's coming together. So now I can label my sides of what they give me. So I have AB is 20, BC is 10, I have EF is 6, DE I don't know. That's our unknown. I'm going to call that an X. So how do I figure out that side? Well, at this point you should see it. We just set up our proportions. So I could say 20 over 10 equals x over 6. That's one of the 4 ways I can set up this problem. And then when I cross multiply, I can do 6 times 20, 10 times x. 10x equals 20 times 6. We'll break out our calculator for that. That equals our 120. 5 by 10. X equals 12. And that's how you would figure out your unknown for a problem that is worded like that. So again, it's just setting up your correct ratios and proportions and then being able to cross multiply.